Hello, my name is Zach Gibbs, and I'm a content developer within education services inside Juniper Networks. And today we will be discussing the Troubleshooting DiffServ-Aware TE LSPs Learning Byte. All right, so let's jump right to the example. Here in the example, we have a topology. Now, there's a lot of routers in this topology, so try not to get overwhelmed by the amount of routers here. And in this topology, it's a DiffServ TE domain. So we have MPLS, we're using DiffServ TE, we're using MAM, so maximum allocation model, bandwidth model, and there are 7 LSPs that come from PE1 and PE2. And so what we need to do is we need to establish a new LSP. It's going to be PE1, PE5 data LSP. So it's going to go from PE1 to PE5. It's going to connect those two sites together. This is going to be a part of class type 1. It's going to need a 200 megabits per second reservation. Now all the links in this topology are 1 gigabit per second links. Keep that in mind. And then we need to set the priority to 0, 0. So that's a 0 setup priority value and 0 hold priority value. So those are the most preferred values. Okay, so I do want to point out a few things here. The shortest path from PE1 to PE5 is through P1, then P3, then PE5. So keep that in mind. That's the path that we're going to want to take, but we might have to take a different path. It all depends on what's available as far as bandwidth. But specifically, I want to point out the link between P1 and P3 is using the 172.16.10.1 IP address, and the link between P3 and PE5 is using the 172.16.12.1 IP address. And those IP addresses are important because we'll be using those IP addresses to look at the traffic engineering database for those links. So keep that in mind. Now, I didn't put the IP address for PE1 to P1 link because there's only one link that is participating in the MPLS DiffServ-Aware TE domain. So keep that in mind when we look at the TED for that router, for PE1 that is, there's only going to be one link. So there was no real reason to specify the IP address there because we won't need to use the IP address to find that link in the TED. Okay, so let's go ahead and jump to the CLI. Okay, so here is the CLI for PE1. Now, we will just be working on PE1. There's no need to jump between routers here because with the TED database, or the TED, which is the traffic engineering database, each router will have a complete copy of it. So there's no need to jump between routers to look at the different TEDs because there's only one TED and all the routers have a copy of it. Okay, so let's go ahead and jump into configuration mode. Jump to MPLS, show what's in here. We have a couple LSPs. And one thing I do want to point out, well, let's do this. And we can see that if we're going to be setting up an LSP that is using CT1, so class type 1, and priority 0, it's going to map to the TE2 traffic engineering class. So keep that in mind. That'll be very important. So let's go ahead and configure our new LSP. That's going to the loopback address of PE5, bandwidth CT1, and we're going to set a 200 megabit per second bandwidth, and then we need to set the priority, 0, 0. Okay, so we got our new LSP. Let's go ahead and commit that. And this will be the last LSP in the list. We see that it's down. Okay, so it's going to recomputate in 24 seconds. Let's go ahead and wait for that. I'll pause the video so we don't have to wait long. Let's check that again. And it's gone through at least one recomputation and still having problems. Now, if we look at the output, it says no route towards 10.10.100.5 2 times. So that's been reported twice. That tells me that there's definitely a problem with setting up the LSP, and more than likely, since we're using DiffServ-Aware TE, it's probably something with bandwidth allocation. So let's go ahead and look at the different routers in the path. It tells us that no route to 10.10.100.5, so let's look at the TED for PE5, see what we have there. We have to use the extensive command to see the information with the traffic engineering classes, and then we can specify the router ID, which in this case for PE5 is that IP address. Okay, so in here, we want to look for TE2. Remember, CT1 with a priority of 0 matches to TE2. And we can see in here that the one link that is participating in the MPLS domain for PE5 shows that TE2 shows that there's 500 megabits per second available. Well, is 500 megabits per second available? More than 200 megabits per second? Yes, of course it is. So that reservation, it's not getting caught up here. So let's work our way back. So the next one would be P3. So that IP address is going to be 10.10.10.3, and we need to actually use the find additional command and search for the IP address associated with that link on P3. And that's that IP address, the 172.16.12.1. And so that'll find and put that at the top of the list. So let me scroll up so we can see here what TE2 has for that link. And we can see TE2, again, 500 megabits per second available. So that is the link going from P3 to PE5. And we see there's 500 megabits per second available. Now, the one thing I do want to point out right now is that we looked at the link coming from PE5 to P3, and that was actually unnecessary. I made a mistake there because, as you probably will know, MPLS LSPs are unidirectional. So we actually shouldn't have looked at PE5. We should have just started with P3. So keep that in mind. We should have started with P3. And we can see in P3 that TE2 does have 500 megabits per second available. So that link between P3 and PE5 is okay. We have plenty of bandwidth available. So let's look at the link between P1 and P3. That's going to be 172.16.10.1 IP address for that link. And we can see here, this is the last link in the output. So it works out well for what we're looking at. But we can see here that TE2 has 400 megabits per second available. Well, that's definitely would allow 200 megabits per second reservation. So we're good there. And so the last thing we need to look at is we need to look at PE1. You know, maybe PE1 doesn't have enough bandwidth going to P1. So let's do that. And PE1 doesn't have more than one link in the MPLS TE or DiffServ TE domain. So we don't need to use the find option. And so let's look at this. Okay, here we see the problem. TE2 only has 100 megabits per second available. That is much less than the 200 megabits per second available that we need. Okay, so what does that tell us? That tells us that if we have to keep that 200 megabits per second reservation for that new LSP, that the LSP is never going to come up. We'd need to either establish another link into the core from PE1, or we need to reduce the bandwidth reservation. So what we are going to do for this Learning Byte is we are going to reduce the reservation for that LSP. So with this LSP, we need to configure it to say bandwidth CT1. We're going to set that to 100 megs, so 100 megabits per second. And that will allow us to establish that LSP across the PE1 to P1 link. That'll allow that to happen. There's enough bandwidth available. Let's go ahead and commit that. And it pops up right away. That's great. We can see that the LSP is up and we are taking that shortest path. So let's take a look at those routers in the shortest path, those links, to see what happened to the TED database or the TED in that instance now that we've set this all up. Okay, so this is the link between P3 and PE5. And let me scroll back up to, you can see this. Okay, so TE2 now shows 400 megabits per second available. Great. Still plenty left. And it was decremented from 500 to 400. Okay, so let's find P1, the link. And we see TE2 now has 300 megabits per second available. It did have 400 megabits per second available. And lastly, let's look at PE1. And we see that PE1 now has 0 bits per second available in TE2. So if we wanted to set up another LSP in that class type, we would not be able to set up anything that would require bandwidth reservation for that class type. Now we could set up something that belongs to CT0 that would then belong to TE0 or TE1. We have available bandwidth there. And so we still could set up additional LSPs, but not any LSPs that use CT1, priority 0, or priority 7. So keep that in mind with how that's currently set up. So that brings us to the end of this Learning Byte. In this Learning Byte, we demonstrated how to troubleshoot DiffServ-Aware TE LSPs. So as always, thanks for watching.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Network's certification program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.